What if I told you that every robot, from the tiny vacuum cleaner rolling around your house to the massive robots building cars, all work the same basic way? They're like digital versions of you and me. They sense what's happening around them, think about it, and then do something about it. Let's peek inside a robot and see what makes it tick. Every robot has four main parts. First is the brain, the controller. This is actually a computer processor that stores all the robot's instructions. Think of it as mission control, telling every other part what to do. In your robotics class, you might see controllers like Arduino boards or Lego robotics kits. Next come the senses, the sensors. Just like you have eyes to see and ears to hear, robots have sensors to gather information. Some robots use ultrasonic sensors that work like bat sonar, bouncing sound waves to measure distance. Others have light sensors to detect brightness, touch sensors that feel when they bump into something, or color sensors that can tell red from blue. Then there are the muscles, the actuators. These are usually motors that convert electricity into movement. Some motors spin wheels to make robots roll around. Others move robot arms with incredible precision, and some can even make a robot spin like it's breakdancing. Finally, robots need a skeleton, their structure. This framework holds everything together and gives the robot its shape. Without it, all those high-tech parts would just be a pile of expensive electronics on the floor. But here's where it gets really cool. These parts work together in a constant cycle. The robot senses something in its environment, the controller thinks about what that information means, and then it acts by moving or responding. Then it starts all over again. It's exactly like what you do every day. You see a puddle ahead, your brain decides to step around it, and your legs carry you safely past. Robots do the same thing, just with circuits instead of neurons. This sense, think, act cycle is what separates robots from regular machines. A washing machine just follows the same program every time, but a robot vacuum notices when it hits your couch and changes direction. That's the difference. Robots can adapt. Whether it's a giant robot building cars, a gentle medical robot assisting in surgery, or a tough explorer robot sending pictures back from Mars, they all use these same four components working together. The amazing thing is that once you understand how these parts work together, you're not just learning about robots. You're learning how to think like an engineer. You're discovering how to break down complex problems into smaller parts and solve them step by step. So the next time you see a robot, remember, it's sensing, thinking, and acting just like you do. The only difference is that instead of a brain, heart, and muscles, it's got controllers, sensors, and actuators all working together to navigate our world. Or even Mars. Pretty incredible what we can build when we understand how the pieces fit together, isn't it?